Okay, so good morning. We start with this course on immunology, and we start with the first. It's okay. Okay. The first question is why we have an immune system. So it's very easy to understand why we have a digestive system, why we have a nervous system. What is the reason to have an immune system? An immune system is motivated. The evolution of immune system was required by the major problem that the microbes dream to colonize a mammalian. So all the microbes around us, the big world of microbes, all kinds of microbes, bacteria, viruses, parasites, dreams to enter and to be able to colonize a mammalian. Why? Why? The why is because we have an unchanging temperature. So as different from other kinds of animals, we have a constant temperature. So if a microbes can adapt to our temperature, it can forever be able to enter and to reproduce inside us. We are providing an unlimited amount of energy. So it means that we have, for microbes, we have an extremely rich kind of food and energy. So it can exploit us in different way. And moreover, we have a blood circulation. So in every district of our body, we have continuously arriving of new nutrients. So we have a constant blood circulation, and moreover, we are very numerous. So a bacterium, a virus which has adapted on you can go invade you, and so also many of us. So these are the major issue which made the microbes dream to enter in us. So the arrival, the evolution of mammalian make a change in microbes' world. And the microbes change it as the majority of microbes try to adapt, to enter, to invade, to exploit our body in order to reproduce. So how is this possible? Because microbes invented very imaginative strategy of invasion and adaptation. So during the evolution of mammalians go along with the evolution of microbes, which invented a strategy to enter in your body, which are very imaginative. Even sometimes are even more imaginative than a movie about the future. So there is a major strategy of entering us and can establish distinct kind of relationship. So the continuous pressure provided by the invasion of microbes force mammalians to develop a sequence of defense mechanism which progressively evolved as the second more complex system of your body. So was a major threat. We are very scared to be invaded by microbes. So we evolved a system we call the immune system as a very complicated, a very sophisticated system of defending from the invasion of microbes, the continuous pressure provided by the possibility of the microbe to enter in us and to exploit our body as a tissue culture. Okay? So, our immune system is a very complicated immune system, which is a superimposition of different mechanisms of defense just to try to control this continuous pressure provided by microbes who can invade us. We are breathing in this room, and progressively this room will be full of microbes which can pass from one of us to the other one, and we must have a mechanism to detect these microbes, to kill, to block, to inhibit the microbes. So the immune system we can consider as a system made by mechanisms and strategies which are very different one from the other one, but are markedly integrated, so intermixed. One can act just because there is another mechanism of defense which is connected to this one. So the first, most evident, is the body barriers. We are wrapped by continuous barriers all over our body, which is called skin, and the skin continue with another barriers, which is a little bit different, which is mucosa, which is more fragile, because of a different function to perform, and all over our body, we are wrapped by these barriers. But once these barriers are breaking, we have what we call the mechanisms, the ensemble of mechanisms called innate immunity mechanism, which are made by the cells of innate immunity and by substances, which I don't know if you already heard about, which are called chemokines and cytokines, and we will go in detail to study what are these substances. We have a system which is very important for defense, which is a complement system, and we have the mechanism of this cell of innate immunity, particularly the ability to phagocyte, to eat the microbes and kill the microbes. And then we have a third line of defense, the third strategy of defense, which is completely different from this one of innate immunity, which is called adaptive immunity. Adaptive immunity is your system can recognize in a specific way the feature, the molecules, the molecular feature of the invading microbes, and make a recognition of the microbes and activate T lymphocyte and B cells. They can guide inflammation. We can produce antibodies which interact specifically with the feature of the microbes. And finally, we have an immune memory. We remember for a long time this kind of reaction, and we perform a very effective defense, secondary defense against this, a subsequent invasion by the same microbe. All these mechanisms are completely different, this one from this one from this one. You will see that mechanism of the strategy used are completely different, but they are completely integrated. So it means that the signal delivered by body barriers, by your skin, by your mucosa, are perceived by the cell of innate immunity. As a mechanism, chemokines, cytokines, and factors released by innate immunity cells are very important to activate the third line of defense, the adaptive immunity. So we have a continuous passage, one to the other one to the other one. And even the immune memory depends, the feature of the immune memory depends on the signal delivered by your body barriers and by the innate immunity. So everything is interacting one with the other one. So apparently the mechanisms are completely different, the strategies are completely different, but if one is deeply connected with the other one. Okay? And even more, the activation of adaptive immunity can guide the mechanism of innate immunity. So very strong interaction and between the various mechanisms of the immune system. So we start with the first line of defense, the body barriers. The body barriers are made by a layer which defend ourselves from the outside. And this provides a physical barrier because our skin is very thick and is able to defend and to define and to protect the inner part of our body very well. But besides the physical barrier, we have a very active biochemical mechanism linked to your skin and to your mucosa. And also, these barriers are alarm barriers. We have many cells of innate immunity which can perceive problems, perceive alteration, perceive the penetration of microbes, and alarm the different part of the immune system. And moreover, on your skin, we have a very strong microbial antibiosis. What does it mean? That the microbes which are able to adapt very well to your skin, to your mucosa, to your gut, are not very happy to see all the microbes arriving. So they secrete a lot of antibiotic substances to inhibit the invasion of other microbes. So the flora of your skin, the flora of your mouth, the flora of your gut is very active in inhibiting the arrival of other microbes. The microbes which well adapted to live on you produce antibiotic substances to inhibit the invasion by other microbes. So let's go to see more in detail the major feature of the human body, the human skin. The human body is wrapped by a continuous barrier, the skin and the mucosa, whose main features are to be resistant, and you know very well that your skin is very effective, much better than plastic foil or aluminum foil you use for the food, because it's very resistant, is elastic, but is impermeable. But if you break your skin is able to close the breakage very fast, so it's self-renewing and self-repairing very quickly. We have a mechanism. The cell of your skin perceive that something is wrong and activated a mechanism of repair. And so immediately you have the wound healing, the healing of the wound. They're able to respond to mechanical stress. So does it mean if you use a lot of your hand, the skin of your hand becomes thicker? If you use a lot of your food, you have a reaction. So this envelope is an envelope which can change, modify in function of your activities. So you can have a skin which is very thick or very thin, depending of your behavior. Is able to react to UV radiation. We have cells which are very sensitive to UV and react to UV. You know that very well. These cells are the melanocyte, which produce a substance, melanin, which change the color of your skin. Sometimes in dramatic way, when you go to the seaside, you become very brown to be better reactive to UV radiation. So all these features make the skin very difficult to be overcome by microbes. For a microbe, it is not easy to enter to new coming microbes. It's not easy to enter inside of our body just because we are continuously wrapped by this barrier. Our skin is producing a lot of substances which are, endowed with antibacterial activity. And also the skin is the skin and the body barriers are responsible for maintaining the thermal regulation. We have a fat layers, which is very important to protect ourselves from the change of temperature of the outside. So let's go to see you have this picture in your book, the picture, typical traditional picture of the skin. The skin is made by stem cell, which are here, and make as a basal cell, which continuously proliferate and produce other cells which progressively move from basal layer to spinous layer, and finally they change behavior. They become rich of various impermeable substance, elastin, and they form the stratum corneum. And you have to remember that every day you desquamate, you release a lot of stratum corneum. When you make the bed in the morning, you see a little bit of powder if you have the sun arriving, and these are billion of cells of stratum corneum which go away. So your skin, your barriers is always renewing very fast. And this is very important because all the microbes which are adhering to the external layer of the skin are removed and go away of your body. You are continuously desquamate, so release outside all the microbes, contaminating substances which are being able to enter the external layer of your skin. But the skin is full also of other cells and of the function. We have the fatty layer here, the fat, which is very important for isolation to protect the temperature of your body. And what else? We have a lot of cells. We have here the melanocytes, which are able to produce melanin, which is a black substance which can be released. But also, if UV ray arrive here, the melanocyte can also proliferate. They change. So these cells have on the membrane some kind of receptor able to recognize UV radiation and to change behavior in function of UV exposure. And that you know very well. If you remain in a room like this one, you will be very pale. If you go to the seaside, you change completely. It's because all over your body, you have these cells which are receptors specific for UV radiation. UV, which are being able to penetrate through the stratum corneum to the granular layer and spinous layer and arrive to this cell and change the behavior of this cell. Then, as you know, we have hair follicle, we have the sweat gland, here, the sweat gland here, and then we have a lot of fibroblasts which provide connect the structure of the basal layer and under the skin, but also we have a lot of cells all around here. So one cells are neutrophil, cells which are very diffuse in our body, which can provide an immediate defense or provide immediate alarm. But also we have designed in green the macrophages, cells which are able to perform many functions. We will see in 20 minutes from now the feature of neutrophil and macrophages. But also we have another very important cell, which is called mast cell, a cell which is full of granules ready to release the contents of the granules outside of the cell. Then we have this kind of cell in green, Langerhans cells, or dermal dendritic cell, which almost are the same, and the different feature which acquire this kind of dendritic cell, which will go in different layers of the skin. And then we have lymphocyte. And okay, so we have this very thick, very articulated structure. So we have a barrier, we have the production of chemical substances through the sweat gland, is rich of salt, is a dry surface rich of salt. So the pH of the skin is acidic, so it's not easy for a microbe to survive on the skin. It's not easy for a microbe to persist on the skin because of the desquamation of the stratum corneum. But even if you can imagine that is very simplified representation. This is the outside of your body, this is the inside of your body, and this can be a capillary, a blood vessel, which lymphocyte with the cell which are moving very fast in one direction. And so you can see the barrier, which is not alone, but is full, as we saw already, of cells, which are able to perceive and to release signal when the barrier is breaking. It's breaking because of an accident, because you shave and you make a mistake, or because you brushes your teeth too much. And so you have always continuously in your life, every day almost, we have some small breakage of the skin. Sometimes you have a big lesion, but in most of the cases it's very limited one, which is immediately perceived and activated a reaction, which is very a complicated reaction, because immediately the cell of the skin release some peptide, some factors, which have an antimicrobial activity. So immediately these poor microbes, which are very happy to finally be able to enter your body, have to deal with factors, and we will see a long list of these factors, released by epithelial cells once they perceive the presence of microbes or the alteration of the continuously surface of the skin. They perceive this breakage of the skin, is that you have a wound or you have a lesion of the skin. So we have immediately the release of this peptide, but also release all the peptide which immediately go to these cells with the alarm cells, which are distributed to your surfaces, to your skin, your mucosa, and can provide alarms, and can also provide alarms which can be perceived by the cell of the vessel, the endothelial cells. We can change completely behavior. So once we have an alteration of your mucosa or your skin, we have immediately the release by epithelial cells of factors to activate the dendritic cell, to activate the NK cell, to activate mastocyte, neutrophil, and other cell, but also to activate the cell on the wall of the small capillary vessels, the endothelial cell. And moreover, we have the release of peptides which can have a very strong antibacterial activity. So even a lesion so simple like the one we break your skin when you make a lesion of your skin, you have immediately this kind of reaction, which can be activated in a few minutes. And the factors which are released are called defensin, alarmins, statins. They are, in general, alarm and danger signal. And you will see a long list in a few minutes of these factors. And more important, also release of chemokines and cytokines. We will discuss in 1 hour or two, what does it mean, chemokine and cytokines. Okay? So the families of molecules secreted by epithelial cells, we have a certain kind of family, the beta-defensin family, the catalysin family, the histatin family. And these are peptides which can disrupt the microbial membranes. They can disrupt the microbial membranes, the majority, so they have a direct antimicrobial activity. The poor microbes, which are very happy to be able finally to enter your body, have to deal immediately with the release of this family of peptides. But also, they can attract dendritic cells, so trigger an immune reaction to the area. Then can be cytokines, and we will see they can trigger immune response. They can, in various kinds, provide an alarm to the other systems, the innate immunity system. And we have chemokines, which are a big family of molecules. We can attract and activate locally the immune cell. So your body, even if the lesion is very minor, immediately trigger a very potent and active reaction. So we have the alarm which follows a lesion when you cut yourself, when you have a small lesion of your skin or your mucosa, you immediately activated a very complicated mechanisms of reaction in very fast period. Few minutes, half an hour, 1 hour, you have the release of all these factors which try to inhibit immediately the invasion by the microbes. Okay? Okay, and then we have another family, alarmins, which are metabolite released by this cell. So we have a complicated series of peptides. So just to be clear for the test, final test, I would like just that they release peptides, cytokines, chemokines, and alarmins. But I don't want you remember all that, absolutely. You will make no question on that. But you must remember the concept. Then we, because of the skin, or because of the blood, we have a substance which is extremely important, which is called lysozyme, muraminidase, which provide another very effective mechanism of defense against the microbes. You already heard about this substance, lysozima in Italian. You already saw it in previous...
Tears.
Well, it's all over your body. We will see. It was discovered by Sir Alexander Fleming. You remember who is Alexander Fleming?
Penicillin.
Penicillin is the one who discovered the penicillin. The penicillin, you know how Alexander Fleming discovered the penicillin? He was a microbiologist. He was culturing bacteria on petri dishes. Petri dishes are round dishes, glass dishes at the time of Fleming, now are plastic. And you have a medium, solid medium, in which you have the microbes growing on the medium. But this Alexander Fleming was a very bright person, but probably not a very compulsive, very attentive scientist. So he forgot one of these plates for a long time outside the thermostat. And what happened? Then this culture was contaminated by a mold, which growing progressively, and he saw that the mold was releasing something, was killing all the microbes around. So we were thinking, okay, the molds are producing some antibiotic substance which can inhibit the growth of all the microbes. And this is a proof of the continuous fighting between microbes, one against the other one. The penicillin, the molds, kill the bacteria, releasing a substance which is an antibiotic substance. And so he was able to purify this substance and was called penicillin. Okay? But at the same time, Fleming a culture against a bacteria, and I don't know if the story is true or not, but it's a good story anyway. Yes, this bacteria, he was working in England. And you know, in England, the weather is not very good in general. Very cold. It's very easy to have a cold. And apparently, this Fleming, this scientist, having this bacteria, had a drop of his nose arriving in, he was examining the petri dishes, and the drop from the nose go to the culture. And instead of throwing away the culture, as every good bacteriologist is supposed to do, if you have a contamination, you destroy, he did, okay, and he put in the incubator and discovered the day after that all around where a drop from his nose arrived in the petri dishes, all the bacteria were dead. So he discovered the presence of a substance in our body, which is called lysozyme or muraminidase, which is a very strong enzymatic activity which destroys bacterial cell wall. So it's extremely important defense mechanism. It is an enzyme attacking the peptidoglycan component of the bacterial cell walls, especially gram-positive bacteria. So the majority of bacteria which are invading our body. This is nothing else than a very important enzyme which hydrolyzes a linkage 1-4 glycosidic bond connecting N-acetylmuraminic acid with N-acetylglucosamine, which is a critical bond of the bacterial cell wall. So it was just invented by our body to destroy bacterial cell wall. So it's an extremely important substance. It is produced by epithelial cells, by your epithelial cell, by your mucosal cell, by your skin, by your granulocyte, which are granulocytes are neutrophils, basophil, and eosinophil, and by monocyte, so by the cell of white cell of your blood. It is present in epithelial tissue and serum, and your serum. You know what is a serum?
Assemblated part of the blood.
Okay.
Also.
Now, the serum is the liquid part of the blood after coagulation. If you have no coagulation, it's not a serum, it's plasma. Perfect. Higher lysozyme concentration are present in tears, nasal secretion, fluid, and saliva. Okay? So, among the substances released by your skin, the one we saw here, all this family of substances, we have an important one, which is the lysozyme. Then we have a more difficult situation. It's very easy, or relatively easy, to protect your body from the outside, because the only function, the major function of the skin is isolation and protection. But it becomes much more difficult to provide a barrier associated with a function. So when you have in your bronchi, we have a problem, the bronchial mucosa, to make a balance between function and protection. We must have a very easy exchange of air, of oxygen arriving in you and protecting sometimes by the outside. And this compromise between function and defense make this situation much more fragile. The majority of infections of human body you will cure when we will be a doctor are happening in the bronchi, in their lungs, in the lung of the person, because it's very difficult to provide a good protection when you cannot have a thin layer of cells. But you have just one layer of ciliated epithelial cell which will protect from the outside, because you must have the air, the oxygen arriving, which can be captured by the blood and transported in your body. So this is one of the fragile points of human body, and is making sense. The majority of bacterial infection is happening in the lung and the intestine. So here, to provide a better protection, we have the release of mucus. This is a creation of mucus, which is a very thick substance, which is a nightmare for microbes. When the microbes is wrapped by the microbes cannot move anymore. It's paralyzed. It's like a jelly substance which immobilizes and blocks the microbe. And here the cell releasing this mucus. And we have this kind of structure, the cilia, which moves the mucus continuously. And the mucus has a new invention to protect a very thin layer where the mechanical part of the defense is becoming a minor, because you have to couple with a very important function, the absorption of oxygen. So the key word is a mucus. Mucus, which is become, when it's more concentrated, as catarrh, and is very important mechanism of defense, because it captures the microbes, and the microbes, when are inside to the mucus, have a lot of problem to survive and to move. Of course, you have always to remember, when we evolve some kind of mechanism of defense, the microbes evolve, a few microbes were able to evolve a contra mechanism of offense. So there are microbes which are able to release an enzyme which can solve the mucus. So there are microbes we can are able to escape to this kind of protection of our body. But for the majority of them, this is a very effective way of protecting. And we have glands which are specialized in mucus production, but also here we have a lot of all the cells are producing mucus, and the mucus is always moving because of the ciliated epithelial cell. Then we have again the mucosa, which is very subtle, the one of your mouth and the lips mucosa, which is still have a very major physical protection provided by the granulous layer and the various layers of the epithelial cells, but it's thinner. We have no mucus production. We have the different part of the area, and we have a lot of this gland, salivary gland, will release a substance full of antimicrobial activity. The saliva, the human saliva, is full of enzyme, full of lysozyme, and have so a very strong antibacterial activity. Even more difficult is the problem of the mucosa of the digestive tract. Here, the problem is a very, very dramatic. It's really a dramatic problem because, as you know, this area is full of microbes. We have what we call microbiome. We 1/3, no, 1 or 3% of your body weight is done by microbes living on you, and the majority of them are living in the intestinal mucosa and colon mucosa. And here we have to manage the absorption of food and at the same time to protect against bacterial infection and viral infection. And here again is a second area, fragile area of our body. The majority of human diseases are because microbes invading the lung or microbes invading the gut, the intestine. And here again, we have the secretion of a mucus. We have a special gland, the goblet cells, and tannet cells, which are releasing these mucus substances, which have a very strong antimicrobial activity. But at the same time, we have a lot of immune system associated with this area. And in the last lesson, we will see more in detail the role of this aggregate or lymphoid cell, which form a very organized structure to defend and to combat the local invasion and release a peculiar class of antibody to block the continuous invasion we can have in the intestine. Then we have again the area in which the colon becomes the rectal mucosa. And the rectal mucosa is again a very fragile area of our body where a lot of infection can take place because the physical protection is minor. We have no mucus release here. And again, it's a very fragile area of our body as the epithelium of the gland penis and the epithelium of vagina. These are very sensitive epithelia, very subtle epithelia, and again, this is exploited by a lot of microbes. You know, the genital infections are very diffuse, another area which is exploited by the microbes to enter your body. The vagina is protected by a mucus layer, which is more effective. But here we have the epithelial gland penis, we have no this kind of protection. So this area which are very fragile area, is very easily invaded by microbes and viruses, which can easily penetrate in the small lesion, which can happen in this part of your body. And also to tell you how imaginative is the way exploited by the microbes to invade your body. You can imagine that a mechanism like this one, which seems absolutely non-realistic. So imagine a microbes, which because of the evolution, because of not done on purpose, but finally evolved a mechanism of invasion like the one of malaria. Malaria is diffused because Anopheles is taking the blood from a person which is infected of malaria. And the parasite arrived on the Anopheles and remained there. When the Anopheles bite another person, in the biting, they regurgitate a little bit of blood of the person bited before. So just very strange. And again, the parasite arrive in the other person. So you can imagine to exploit something fantastic, something flying from person to person and to diffuse a disease which remains the intestine, and this a long proboscis which arrive to take the blood, the small capillary from one person and to diffuse the disease to the other one. But we have 1 million of people nowadays in 2018 which are dying of malaria. So this passes through mosquitoes is a fantastic way to diffuse something which appears completely not logical, very improbable. If you can imagine a movie in which you have an alien person arriving in your body because a flying animal. So it's very strange. But this is an example how the microbes continuously are trying to evolve a mechanism to enter inside of your body or the body of your patient and exploit the body to diffuse, to proliferate, to create a new relationship with the person. And in many cases, this relationship can evolve in a very serious disease. Okay, I think I finished this first part. So we have 2 minutes of interval, and we pass to the second one. Do you have questions? Everything was clear? Yes. I need help. Come faccio ad andare all'altra? Ok.
C'è un'altra diapositiva, c'è un altro
No, ci sono tante altre, sì.
Il coltello l'abbiamo portato? No. Non possiamo giocare la buccia qui, qui scherzo.
No, questo.
Senza la vita, però lo portava la porchetta comunque. Trovato, non sta qua, Stefano. Oggi ci ho pensato e detto, lo metto io subito, non lo scordo dopo scrivere. Io li sono portati, non mi piace. Fai che portati? Perché la chiamata dipende di pranzo, cioè di quando la cittadina a pranzo. Se dobbiamo cucinare comunque torniamo a casa.
C'è dell'acqua?
Cioè questo è l'ambiente, quello è freddo.
Oggi sto pregando in palestra e sto pensa al microfono.
In realtà c'è un'altra parte. Ah, non c'è.
5, poi N, piccolo N, piccolo, poi parentesi, quadra,
No, è giusto, solo che sono...
sì, poi F, piccolo.
Guarda, un perché una tazza bianca. Cioè, guarda, non so, fatta una seconda. Così la vuoi. Metti adesso fuori. Questo.
Oh, strano però. Quando ho fatto due storie però non si mette.
Sì.
Tutte e tre erano così.
Non lavoro degli però devo solo sì.
Io voglio un caffè.
Dopo? Prossima sezione.
Già? Sì, giù. Giù, noi facciamo una di sempre. Come è andato il viaggio? Sei arrivato? Sei sera?
Un'ora e mezza.
Io ho trovato un treno
È bellissimo. Cioè tu a Mestre hai scritto Bellinzona sul treno.
Io ho deciso quando scendere, quindi. Avevo deciso quando scendere. 24, 24. Però il 23 era la mia.
22.
Il 23 mi sa che prendo il
No,
treno.
solo i treni, ma
No, perché-
se non sei in via, mi troverà già. Perché non ci sono tutti.
Quindi l'esame di fonologia sarà il 20.
No, il 22
Okay, now we pass to the second part of today's lessons, which is about the cells, the feature of the cell which are associated with the mucosa and to the skin, to our barriers. So a series of cells which we call sentinel cell, the cell which can outpost of our body to perceive trace of damage damage or microbial invasion. They can perceive damage. So from the skin, there are signals which are delivered by the skin, the altered skin can release a signal which can perceive by this cell or the microbes which arrive in our body. And we have a group of different kinds of cells. We have the epithelial cells which deliver a signal, as we saw before, but we have a mastocyte, which are here, can release the contents of the granules. We have the granulocyte, neutrophil and eosinophil. We can have a series of lymphocytes, which are of different kind, and we have a lot of dendritic cells and macrophages, or natural killer cells. And what is very critical also is the capillary of the post-capillary venules, the wall of this cell, which have this kind of cells which are extremely important, the endothelial cells, which react in various kinds to the signal delivered by any kind of alteration and invasion. So the alarm signal following a body barrier lesion are made by the components of the blood coagulation, are the peculiar metabolite released by the cell which are dying, the cell which are suffering because the physical lesion. We are due to the complement activation. The complement is very complicated system we will see after tomorrow probably, and cytokines and chemokines, some molecule we will see later this afternoon, later today. But then we have also series of signal of alarm, the one we saw already before, the metabolite of ATP, adenosine uric acid. We have a lot of very reactive substances we are called reactive oxygen intermediate of ROI, which are molecules which are very reactive. They alter the normal configuration of a protein. So they are very strong antimicrobial activity, and other molecules which are called heat shock protein, other kind of messages inside to the immune system. Then we have low density lipoprotein, metalloproteinase, neuromediator, vasoactive intestinal peptide, and we have DNA, RNA, which are released by the dying cell. Hypoxia, which is very difficult situation, low oxygen concentration in the area, which trigger a lot of reaction mechanism. Breakdown product of extracellular matrix and debris remnants of the dying cell. All this can provide a signal of alarm. So it means the sentinel cells must have a receptor on their membrane to perceive component of cell coagulation, to perceive remnant of the dying cell, to perceive a condition of hypoxia, to perceive the presence of metalloproteinase, to perceive the presence of purine metabolite. So all these cells in the black of your body, in the completely black, they must have on the membrane a series of receptors to perceive, to interact to every one of these molecules and to transform the binding of this molecule to the receptor to a signal. We will change the behavior of the sentinel cell. So you have to always imagine this complicated immune system working complete in the dark. I make a series of drawings, but you have always to remember the cell has no eyes. So all the communication of the cell is through the receptor, a cell expressed on the membrane. There are cells which have a few receptors, there are cells which are very sophisticated, have many different receptors. And the interacting of the ligand with the receptor deliver a signal which change the behavior of the cell. Okay, so the behavior of lymphocyte we will see in tomorrow is completely due to the different signals, the integration of the different signal perceived by the different receptor expressed on the cell membrane. So all these sentinel cells have a very variety of molecule, receptor molecule, which perceive different kinds of signal. And they decode the situation of the environment and change the behavior of the cell. This is a very critical concept. I hope it's clear. So you can imagine this is receptor for something. If the ligand interacts with this receptor, a signal is delivered to the nucleus and the cell can change behavior. But also if this signal go along with this signal and this signal, the cell will have a different behavior. So the modulation of the behavior of the cell depends on the integration of the different signal arriving to the nucleus of the cell. Integration of different signal. And here we have signal for what we call danger signal. So what we saw before, alarm means debris of the cell, situation of hypoxia, all that we have different receptors which recognize this kind of signal. Then we have signal we recognize dead cell and damaged tissue. Then we have a receptor who recognize the presence of microbial molecules. There are molecules which are not commonly present in our body. The presence of this molecule means there is a contamination, there is an invasion on point. So, because of this receptor receives something, they deliver a signal, say, be careful, we probably are dealing with a microbial invasion. The receptor for nucleic acids, all these receptors all together are forming a family, very important family. You have to remember that. Pattern recognition receptor, PRR. So are the receptor which recognize a different kind of signals all linked to a probable invasion or damage of our body. Pattern recognition receptor is a big family of receptors recognizing danger signal, dead cell, microbial molecules, or strange nucleic acid present in your body. Then we have a receptor for cytokines, which are molecules of communication of the immune system. We have a receptor for chemokines, which are other molecules of communication of the immune system. Then we have a receptor which allowed the interaction of one cell to the other one. Probably you already saw this receptor in histology. The receptor attracting one cell to establish a temporary interaction with another cell. It's not the deep bound of the cell of the same tissue. This is a free cell which establish a temporary interaction only. Then we have a receptor for hormones and receptor for complement factors, which are extremely important, and finally, factors for the antibody. And we will see in detail many of these receptors during the various lessons. The one we have to consider now are the receptors, the pattern recognition receptor, which are the one which can tell your body or the cell to your body that probably you are dealing with a microbial invasion. So a microbial invasion is perceived through numerous pattern recognition receptors, PRR, present on sentinel cells. And what I hope you have very clear on you is that this is a thing, is a ligand, can be a dead cell, can be a debris of the cell, can be nucleic acid released by the virus, nucleic acid released by the dying cell, can be many molecules linked to microbial invasion, to damage of the tissue, which can interact very well with a specific receptor, and this transduces the signal to the nucleus. And the cell and the behavior of this cell, the green cell, is not anymore the same. The cell will receive a signal and will change the behavior. Perhaps can try to move, perhaps will try to produce enzyme, perhaps will decide to divide in response to the signal which is transduced to the nucleus. Is this concept clear today? Yes. We have pattern recognition receptor on the cell surface, can perceive. There's a big family of this receptor, a very strange name. I wanted you to know what the name are, but you will not be asked of the name on the test. But you have to remember that our NOGLI receptor, our scavenger receptor. Scavenger is the one who clean up, to clean up your body. A receptor of C-type lectin, so with sugar on the membrane, are the big family of toll-like receptor, which what recognize? What is the ligand which can recognize by each one of these receptors? They recognize danger signal and alarm signal. They recognize a typical molecule of microbial world, LPS, lipopolysaccharide, which is a typical product of almost all kinds of microbes, which is not produced in our body. So the presence in the body of a patient of LPS tell immediately to react because we are dealing with probably a microbial invasion. Flagellin. Flagellin is a component of the flagellum of microbes. So again, a structure which should not be present in your body. If you have flagellin around us, it means you have an invasion of microbes, so you must be in alarm. Microbial molecule, damage molecule, lipid and lipoproteins released by damaged cell and microbe. Sugar, which are typical of microbes, kind of sugar you don't have in your body. So the interaction with sugar means you have a microbe invasion. Viruses and fungi and stress cell is lipoprotein, lipopolysaccharide, heat shock protein, flagellin, and formylmethionine peptide, a typical component of microbial metabolism. And again, inside of you, if you're healthy, you have no this kind of peptide. The presence of this peptide means there is some microbes which are proliferating inside to your body. So you must be in alarm. These are the ligand perceived by this very large family, extremely important pattern recognition receptor. What does it mean, this name, pattern recognition receptor? A receptor will recognize a series, a pattern of behavior cells, a very large family of cells associated with damage and invasion. So they perceive the signal, the initial signal of the presence of body exogenous molecule, extraneous organism entering your body. A microbial invasion is perceived through a pattern recognition receptor, which has present sentinel cell, which can be on the membrane as before, but which can be also inside. There are some viruses which are able to enter the cell, and inside we have pattern recognition receptor or endosomes, the vacuole of phagocytosis. On that, we have a receptor which recognize CPG sequence, cytosine, phosphorylated and guanosine sequences, typical of microbial world, a structural nucleic acid which are not present in your body. That recognizes single and double-stranded RNA, single and double-stranded viral RNA, LPS, microbial molecule. So even inside, even if a microbe is able to enter and to be enclosed in the vacuole of phagocytosis, we have a receptor. We recognize that inside the cell, invaded by a virus, invaded by microbes, there is something which is not regular, is not normal on the cell. And these are pattern recognition receptor or on endosomes. So a typical question will be on your final test. Are pattern recognition receptor only on the surface of the cell? Or the answer is no, they can also be inside to the cell on endosomes. I don't want you to remember the name, this specific name, but I want to remember the concept. What are the pattern recognition receptor recognizing? They are recognizing signal linked to tissue damage and microbial invasion. In general, each receptor is very specific for a signal difference. So we have many of these receptors decoding signal, different kind of signal linked to an alteration of your normal structure. But also pattern recognition receptors which are diffused in the cytoplasm, not only on the endosomes as before, but intracytoplasmatic pattern recognition receptor, which recognize typical, they are very important during viral infection. The virus enters the cell, can diffuse inside the cell, so they recognize a double-stranded RNA. We don't have inside us, we don't use double-stranded RNA. We use double-stranded DNA, but double-stranded RNA means there are something, a molecule which should not be in your body. So if inside to the cytoplasm, exists double-stranded RNA, you must react. Something is wrong with the cell. The cell is invaded. It's not producing anymore your protein by producing viral protein. It recognizes single and double-stranded viral RNA, viral and microRNA, viral and microDNA. So these are different kind of group of family of receptors. So you can imagine how many of these receptors every cell has in order to recognize many, many different signals linked to a microbial invasion. And these are family of node-like receptor, rake-like receptor, DNA helicase, and DNases, all inside our pattern recognition receptor inside to the cytoplasm of the cell. So once the pattern recognition receptor recognizes the different ligands which interact with him, he can make a reaction. And just to provide you an example, this will make sense when we go along with the course of immunology. But you can see the node-like receptor, when they interact with the ligand, organize a structure which is called inflammasomes, organize it and induce the production of interleukin 1, interleukin 18, interleukin 33. Makes no sense now, but it means the cells change behavior and produce a organize a molecular structure called inflammasome to produce this kind of cytokines. The scavenger receptor is they interact with cell debris, remnant of the cell, triggers the phagocytosis, the secretion of pro-inflammatory cytokines, and production of ROI, reactive oxygen intermediate, which alter the protein of the cell nearby. The CYP lectins can trigger phagocytosis, release of pro-inflammatory cytokine, ROI production, increase of adhesion molecule. So the cell can better interact one to the other one. They can release a protein with antimicrobial activity, can activate the complement cascade. The toll-like receptor can produce antiviral, antimicrobial proteins, secretion of pro-inflammatory cytokine, and again, this kind of reaction, which is always quite similar. In this case, can produce another molecule called interferons. We will see in a few minutes what does it mean, this molecule. And the DNases can destroy viral DNA, release of interferon and other cytokines. So this, excuse me. We saw the big family recognized of a foreign molecule recognized by the pattern recognition receptor. And here we have the typical kind of reaction activated by the interaction of this receptor with the ligand. They induce various activity of the cell. We will see many times during the different phases of the immune response. What are the cells doing in peculiarity? So the epithelial cells, if they perceive the pattern recognition receptor of epithelial cell recognize traces of invasion, they secrete antimicrobial peptide, they stimulate the mucus production. So we have over mucus production, we have the catarrh, we have during the flu, during the cold, we have all hyper mucus production because the epithelial cell, mucus growth factor and cytokines. The mast cell and basophil, they release vasoactive mediators. They change the dimension of the blood vessel arriving in the area. The neutrophil, they do secrete peptide, cytokine, and chemokines, and all that we will see in detail. What are doing the different kind of cell, those pattern recognition receptor recognize something foreign. So we saw the mechanism activated. We saw first what are recognizing pattern recognition receptor recognized. Second, what are the pattern recognition receptor inducing? And third, what in following this kind of signal, the different cells of innate immunity of your body are producing, are releasing pro-angiogenic factor, are secreting cytokines, are activating peptide, are releasing or different kinds of signal which trigger an inflammatory reaction. So, trying to put together all this signal. Once we have an alteration on your surfaces, or your gut mucosa, of your mouth mucosa, of your skin, you have reaction signals delivered by epithelial cells and by released by the microbes, and this can perceive by a series of receptors present on the epithelial cell, present on each one of these cells. Every cell has a different kind, a different combination of receptors, and they can perceive different signals due to the invasion, to the damage of the tissue, and elaborate a reaction. The reaction elaborated after all this signal is going to activate the cell of the wall of the more capillary tissue, capillary vessel, the endothelial cell. And the first reaction is a change of the behavior of their vessel. The area became irritated with vessels which are larger. More blood arrives to the area. Every time you make a lesion of your skin or your mouth, you perceive that the area is becoming reddish because the vessel from a previous dimension changed completely the dimensions. The vessel enlarged and the area became red. Why was the red? It means a reaction when you see any area reddish, means you have a dilatation of the endothelial cell of the vessel. Not only less 101. We have an area, we have a window between one cell and the other one. They dilated, they change also on the surface. They express a lot of adhesion molecules. So the signal perceived by the different kind of cell, signal released by the epithelial cell damage, act on the endothelial cell. The endothelial cells change the number of adhesion molecules expressed on the membrane, and they dilatate. The vessels become larger, more blood arriving in the area, but the cells do not have anymore the tight junction they had before, but we have a window here where from this window, what is going out? The blood, the serum, the plasma is going in the area of the invasion. And so the area of the invasion becomes thicker, denser, you know very well, swallowing the area. Why? Because the plasma is going to invade this area. The plasma of your blood is full of antimicrobial activity, is full of lysosome, is full of antibacterial substances. So the poor microbes which are invading here, now we have to deal with a lot of components from the blood which have antimicrobial activity. Okay? But this is not enough. Since they have adhesion molecule, the cell of the capillary can move through this window, adhere to this cell, and sneak through, go out, marginate, go out from the vessel and go to the periphery. A phenomenon which has many different names is called margination or extravasation, going out of the vessel. And what are the cells which are going out first? Are the neutrophils. Why are the neutrophils going out first? Because they have what? What is the peculiarity of the nucleus of neutrophils? Probably you saw already in histology. They don't have a nucleus around nucleus, but they have a nucleus which is made by different area, very strange nucleus. What is the reason for that? The possibility to sneak through this small window and to be the first going out. So, there is another part. These neutrophils are the first which are going out because of the peculiarity of the nucleus. This speak about okay. Then here there is a population of cells called innate lymphoid cells. Very important sentinel cell. Very important family of sentinel cells, which are innate lymphoid cell, which is an heterogeneous population of lymphocytes present at the barrier surface, skin, bronchial mucosa, mucosa of the digestive tract, mucosa of the gland, penis, the vagina, but rare in the lymphoid tissue. They have a very important sentinel function. They promote acute inflammation. They change the behavior of macrophages. They trigger the mucus secretion by the globule cells. So you produce a lot of mucus. They trigger the secretion of antimicrobial factor by PANET and epithelial cell. And they have different kind of innate lymphoid cell. They do release different kind of combination of cytokines, and they induce different kind of function. Okay, I don't know, is it possible to link it to internet to see a movie? Mm-hmm. Can you help me over there?
Our bodies are in constant contact with environmental factors. Epithelial barriers, like the skin or gut mucosa, represent the first line of defense. In the gut mucosa, specialized immune cells actively reinforce the barrier and induce tolerance against food or commensal bacteria. Among these immune cells, a recently discovered type of lymphocyte called innate lymphoid cells, or ILCs, orchestrate immune responses and maintain tissue homeostasis. Unlike the T and B lymphocytes, ILCs do not express adaptive antigen recognition receptors. As such, their activation and expansion is not driven by antigen, but rather by cytokine signals from the tissue. ILCs come in three types: ILC1, ILC2, and ILC3. ILC3s interact with dendritic cells to maintain the epithelial barrier. Dendritic cells, which are specialized in the presentation of antigen, acquire antigen from the gut microbiota and secrete interleukin-23. IL-23 stimulates the ILC3s to make IL-22, which then activates the epithelium to secrete antimicrobial peptides, or AMPs, that kill bacteria directly. IL-22 also enhances IL-23 production in dendritic cells. This dialogue between dendritic cells and ILC3s maintains the barrier against pathogenic or commensal bacteria. ILC3s also interact with macrophages to establish tolerance towards the commensal microbiota. Antigen from gut bacteria induces the inflammatory cytokine IL-1 beta in macrophages, which in turn triggers the secretion of GM-CSF in ILC3s. GM-CSF signals back to macrophages to induce retinoic acid, which promotes the differentiation of regulatory T cells. Regulatory T cells are essential in maintaining tolerance towards the commensal microbiota. ILC2s contribute to responses against helminths. These parasitic worms release enzymes that digest the mucus barrier and cause massive cell death. Epithelial cells sense the danger signals released by the dying cells and produce alarmins. In response to the alarmin IL-25, ILC2s make mediators that induce mucus production from goblet cells, send activated dendritic cells to the lymph node where they can prime T cell effectors, recruit eosinophils and mast cells, and induce muscle contraction. These actions result in the expulsion of worms from the gut. In response to IL-33, ILC2s also make amphiregulin, which induces tissue repair following worm clearance. However, ILCs also contribute to tissue pathology. ILC1s, which make the inflammatory mediator interferon gamma, and ILC3s, which can acquire the ability to make interferon gamma during chronic inflammation, are found in inflammatory bowel diseases such as colitis and Crohn's disease, and contribute to gut pathology. As such, ILCs participate in various aspects of immunity, from maintenance of the epithelial barrier and tolerance against commensals, to immune responses against parasites and pathology associated with chronic inflammation.
This is very nice movie, isn't it? And put together many things we already saw. Thank you.
Questo va giù.
L'ultimo, andiamo avanti.
Cioè,
Okay, we have the third introduction. So we saw the barriers, we saw a little bit of the signal and the cells which are involved in alarm reaction and provided they recognize a different signal of invasion. And the final event of the result of all this signal and recognition is the innate immune reaction, the activation of innate immune reaction, what you know very well with the name of inflammation. the inflammation, which is a very fast and very violent, very strong reaction. Your body tries to combat as maximum as it can the invasion of microbes as a consequence of all the signal he received before. And I say fast and furious because this reaction is taking place in few hours after the microbial invasion, but few hours after microbial invasion, and is very, very strong. So strong that the majority of you will use with your patient anti-inflammatory substances because this reaction is too furious, is too violent, is too strong in general. This is to be well understood. The majority of the symptoms linked to the influenza, to the cold, are due to this reaction, not to the virus invading your patient, but the reaction, innate immune reaction, which is sometimes so strong to damage the body. You saw already mentioned in the movie we saw that sometimes this reaction is triggering autoimmune disease. And every time you have a strong inflammatory reaction, you have a risk to have damage for that. But from an evolutionary standpoint, when the life of human life was normally of 25 years, and this was the period of life, this kind of reaction was very logical, was maintained in evolution. So you have to understand well this contradiction between this reaction, we will see, I will show you, which is a very important. Without that, we will not survive. But at the same time, this reaction is too much, is always a little bit too much. And we try always to dump, to inhibit, to decrease this kind of reaction. And this, I'm sure a lot of you have already taken in your very short life, already many times, anti-inflammatory substances. So, this reaction is very efficient, but at the same time, remember, it's very dangerous. So again, the scheme as before, very simple. We have the sentinel cells. The sentinel cells are full of pattern recognition receptors. They perceive a lot of damage due to tissue damage, to microbial invasion, and react to this signal, releasing signal which act on endothelial cell of the vessel. The vessel change the behavior. They release this kind of window between one cell and the other cell. A lot of blood components go in the area of the invasion and kill the majority of the poor microbes who are very so happy to invade and then are immediately killed. But through this window, neutrophils, thanks to the structure, the peculiar structure of their nucleus, are able to sneak through to the small window which are formed between one endothelial cell and the other cell. And they are attracted by the signal perceived by the pattern recognition receptor and by the signal released by mastocyte and other sentinel cell in the area of invasion. And they go there and start to combat the big battle to inhibit microbial invasion. So we pass from the barrier to the inflammatory response, which is called innate immunity reaction. We saw that barriers are instrumental, are required to guide the inflammatory reaction. If not, the the time are minutes and we pass to hour. So barriers are always operative. In this moment, all your barriers are active, but if you have an invasion, in hours, you trigger an inflammatory reaction. And we have a local or diffuse war to repress the invaders. Normally, the war is very localized. Every time you have a small inflammation in your skin or your mucosa is very small, but sometimes the battle can be a major battle. You can have area disease. Okay? So we call fast and furious. Okay, we have a very rapid and very intense reaction, very efficient, but potentially dangerous. Potentially, I don't know what's happening. Okay, you have here another representation of the same issue. So the endothelial cell of the vessel changed. You see here very well designed the neutrophil, which is able, thanks to the structure of the nucleus, to be the first one to sneak through, to go out of the vessel and to go to the area where it participates to reaction. And you will see a lot of neutrophils die in the reaction, release the contents of the granules, and we have this big battle locally in order to immediately block, to destroy the invader. And we have initially, we have neutrophils, which are the first one, since the lesion is small. As the lesion becomes larger, other kind of cell can go out from the vessel. The monocytes, which are very large nucleus, you will see in a few minutes, which are also able to go out. And progressively, we have an organized local inflammatory reaction. In some kind of diseases in which you have the microbes going around your body, you might have a diffuse inflammatory reaction. But normally, this is reaction localized in the area of the invasion.
Normally, basophils are involved in local reaction.
Sorry?
Normally, basophils are involved in local.
Normally, it's local reaction. But with certain kind of diseases, we have a very general reaction. I think in your life, many times you had this kind of local reaction, which can be in your mouth, it can be in your body. When you did something on your skin, you have this kind of reddish area and you have a reaction. Sometimes you have a lot of this cell dying and you have the formation of what we call, when you have a lot of dying cells, when you break your knees and going on the bicycle, what do you have? Production of?
A lot tumor necrosis.
No.
That's
something very physical. You happen when you were a child going with a bicycle, and you have this kind of reaction locally, and at a certain point, you have production of pus.
Ah,
Pus. Pus, what is pus? Pus is DNA released by the cell, debris of cell, but the majority is DNA going as a gray matter because a lot of innate immunity cell, mostly neutrophil, are dying when they try to inhibit, to combat the microbes. And they release the contents of the nucleus, which in form of pus. So this reaction, I told you, is very efficient, but potentially dangerous and distressing. Means people don't want to have this reaction. You don't want, you as a doctor have to try to inhibit this reaction, because this reaction is characterized by this Latin word, rubor, dolor, et functio lesa. It means red. Why is red? Because the vessels are dilated, a large vessel, and so is reddish. Dolor, because you have a lot of edema, a lot of liquid from the blood going to the area and making alterations in nerve, sensitive nerve, and function laser. The area can perform very poor function, can work poorly, because it's invaded by cells and by liquid from the blood. And what are the reaction when this reaction is more generalized? Is shivering. You are doing that. You have malaise, so you have headache, you have fever, you have nausea. So all the symptoms of influenza are not due to the virus invading the body of the patient, but are due to the mechanism, to the consequence of the cytokines and chemokines and interferons released to react in this inflammatory reaction. Because of that, you provide to the patient with aspirin, with other substances, with paracetamol, which inhibit this very important natural function. So this double-edged situation, inflammatory reaction, very important, very effective, but sometimes dangerous and providing distressing. So the patient don't like to have this kind of inflammatory reaction. So this inflammatory reaction is given by the cell present in the blood, which go out for the blood vessel. And white blood cells are the white cell present in the blood. And we have, this is the data the laboratory tell us of amount of white blood cell for microliter of blood. And as probably you know very well, we have this kind of population of cells: basophil, neutrophil, eosinophil, monocyte, and lymphocyte. These three are called also granulocyte, and the other one a little bit different. And they have a different percentage in our body. Probably you already know that, but basophils are very rare, are non-existing on 100 cells, or very few normally, 1 every 100 cells. So very rare basophil in the blood, but more present in the tissue as a form of different cell, mast cell. Then we have neutrophils, which is a majority of the cell of your blood, between 40 to 70%, 75%. Then we have eosinophils, which are very rare in general, but can be more diffuse in other situations. We have monocytes, which are between the 3 and 10%, and we have lymphocytes between 20 to 50%. Okay? This is a general composition of your blood. And the fact that this composition remains the same, means that we have mechanisms inside our body which are able to count and to regulate very well this percentage. Because when you have more of that, or you have more of that, you have an alarm. As a doctor, you make an exam and say, oh, too much monocyte, too much lymphocyte. They have dysregulation. It means they are signal to which the production of this cell react, which an overproduction of certain kind of this kind of cells. So first of all, the production of this cell is very tightly regulated. So in all the human population, in normal condition, all the billion of human body existing on the heart have the same percentage of cells. This regulation out of this percentage, more of that, more lymphocyte, more eosinophil, more neutrophil, more basophil, tell you that something is inducing an overproduction of this cell. There are signals which are changing the normal bone marrow production of this cell. All these cells, as you know very well, are produced by the red bone marrow in very complicated way, in different area, with different organization. As the cell mature in this area and finally go out into the blood when they acquire a maturation stage. But this maturation is very much influenced in order to maintain constant on you the percentage we discussed before. And I think this is already familiar to you. You probably already studied that. From hematopoietic stem cell with a myeloid precursor from which derives the erythrocyte, derives the platelets, derives the basophil, mast cell, the eosinophil, the neutrophil, the monocyte, and from the monocytes, the macrophages, and the dendritic cells. The different kind of differentiation of this cell of the myeloid part. And here is appearing the lymphoid part. And this is regulated by factor released by the cell of the bone marrow, which can able to perceive how many cells we have in periphery. So we have a continuous control of the differentiation of the cell. This is the lymphoid part, and so the first major division is myeloid division or lymphoid division, and this is a B cell and the T cell, which progressively divide in other subpopulation. Okay? This is a traditional view of the maturation of the cell. We have a more than, okay, we can see this movie later on, but we have a modern view, which is this one, which has just appeared on Nature a few weeks ago, which is, we have a hematopoietic stem cell, we have factors acting here and inducing the first big dichotomy, myeloid and lymphoid cell. And erythrocyte and megakaryocyte first, and then here the second big B cell, T cell, NK cell, and here there's a differentiation. But a single cell transcriptomics net spot show a continuum of differentiation of blood cells. Humans produce 1.4 to 10 to 14 major blood cells a year. So every day we produce billions of cells, which needs to have a flexibility to adapt to change on demand. What does it mean, change on demand? We have an inflammation, we have a disease, and so we have to increase the production of that. We have a disease which will destroy erythrocyte, we have to have an hyperproduction, so we have to change the flexibility of this maturation due to ability to change depending on the situation of the peripheral demand. let's say you have malaria, which kills your erythrocyte, you have to produce overproduction of erythrocyte, or so on. The cell fate decision. So here the cell decided what would be the destiny of this cell, becoming an erythrocyte or becoming a dendritic cell or becoming a macrophages. The cell fate decision entails a choice between alternative gene expression programs. So the signal which are perceived here influence the kind of genetic program which will be inhibited and the kind of genetic program which can be activated. And then this is a first decision. Then here is a critical decision. Again, this genetic program have different kind of branches. Some can be inhibited, some can be activated. Here against a decision, and here against a decision. So every time the cell has to decide what is the gene expression program to be activated in response to extracellular signal, to hormones, to chemokines, which influence the kind of decision in every critical point. Individual single cells select one of these different gene expression programs. Okay? Transcription factor bind to specific sequence motif with gene promoter, enhancer, and silencer regions, and recruit epigenetic regulator to modulate the activation status of a gene, which is transmitted to a subsequent cell generation as epigenetic memory. So the DNA doesn't change, but change the activation of repression of a different program. So the various cells have a epigenetic memory, the structure, the accessibility, the methylation of DNA change. So a dendritic cell has a program, genetic program, accessibility program, which are different from one of monocyte, which are very different from one of eosinophil, and very different from the one of eosinophil. Are factors which make the cell to select the destiny, and the destiny means activation of certain program, inhibition of other program through epigenetic changes. So certain area of DNA become not available, become methylated, become tackled by histones, so not accessible, other becoming extremely well accessible. Okay, this fits well with what you already studied in histologies, okay? Lineage choice means that one program is winning out, while the alternative program is extinguishing. So you inhibit and you activated something. All the cells have the same DNA, but the same DNA is not equally accessible because epigenetic modulation of the DNA. So an erythrocyte, which erythrocytes have no DNA anymore, but a megakaryocyte has the same gene of all the other one, but the program, the activation, certain kind of genes are not available, are being blocked by different conformation of the DNA, histone, and methylation. Can we see the movie, please? This one is not as nice as the other one, but it's okay. So.
I'm going to start by drawing a blood vessel. And inside the blood vessel, I'm going to draw in all the cells that you'd expect to see in normal blood. So I'm going to put in a few red blood cells. I'm going to draw in a couple of platelets, which are just fragments of cells. And then I'm going to put in a few white blood cells. And even though all of these cells are found in the blood, they're actually not made there. So the cells in the blood are made inside the bone. And if you were to take a cross-section of bone, so if you were to take a slice like this and you looked at it, you'd see that on the inside of bone, there's a central cavity. So this is the outside part of the bone, the hard part, and this is the central cavity. And inside that cavity, there's this red spongy tissue. And that stuff is called bone marrow. Bone marrow. And bone marrow is where all of these blood cells are made. So it's the site of hematopoiesis. So hemato means blood, and poiesis means to form or to make. So hematopoiesis is just the scary Greek word that means to make blood. So let's take a look at what goes on inside the bone marrow. So what's interesting is that as different as all of the blood cells are, they all actually originate from the same cell. And that cell is called a hematopoietic stem cell. And this stem cell gives rise to all of the different cells that you see in the blood. And so it gives rise first to two different cell lineages or two different cell groups. So first there is the myeloid group, group, which is different from the lymphoid group, lymphoid group. So all of the cells that you see in the blood belong to either the myeloid group or the lymphoid group. And the lymphoid group includes two different types of blood cells. So first there's the T cell. Actually, that's too big because this is a very little cell. So that seems about right. So there's a T cell, and the majority of the cell is taken up by the cell's nucleus. And that's what I'm shading in over here. So much so that this cell has a nickname. It's often referred to as a naked nucleus because it looks like the nucleus isn't surrounded by very much cytoplasm. So this is a T cell or a T lymphocyte. So a T lymphocyte. And it's very similar in appearance to the other type of lymphoid cell. So this cell also has a nucleus that takes up the majority of the cell. And this cell is a B cell or a B lymphocyte. So B lymphocyte. So those are the two different types of lymphoid cells. What about the different types of myeloid cells? Well, for starters, we have a red blood cell. So I guess we should draw that in red. And this is also a very small cell. And I'm going to shade in this cell so that I can show you that the center of the cell is much lighter than the edges or the periphery of the cell. So this is not the cell's nucleus, guys, because we know that red blood cells don't have nuclei. What I'm trying to show is that the center of the cell is much lighter than the periphery of the cell. And I guess I could do a better job of that if I showed you what the cell looks like on its side. So this is what a red blood cell looks like when it's laid on its side. And it kind of looks like a dumbbell where the edges are much thicker or much wider than the center. So the edges would, since they're thicker, they would be much more densely packed with hemoglobin. And since we know that hemoglobin is what gives red blood cells a red color, the edges would then be darker than the center. And since the center is much thinner, it would have a lot less hemoglobin. And so it would be a lot paler in comparison. So we said that this is a red blood cell, but since in science we never use the plain and ordinary name of things, we call this an erythrocyte. Erythrocyte, which is just a fancy name for a plain old red blood cell. So what are some of the other types of myeloid cells? Well, we have this one cell that I'm drawing in over here. You might say, well, that looks nothing like a cell, and you'd be totally right. This is a very odd looking, very large cell, and it's called a megakaryocyte. And even if you've never heard of a megakaryocyte before, you may have heard of what it gives rise to, because a megakaryocyte gives off little blebs of its cytoplasm to form these small cell fragments. And these fragments are known as platelets. So you may have heard of the platelets before. So the rest of the myeloid cells are actually different types of white blood cells. So for example, you have this one type of white blood cell, and the rest of these white blood cells are about twice the size of a red blood cell. So that looks like it's twice the size of a red blood cell to me. So this cell is called a monocyte, and it's known for having this nucleus that's in the shape of a kidney bean. That kind of looks like a kidney bean to me. And this is a really cool white blood cell because it protects us from bacteria and viruses and other invading organisms, just like any other white blood cell does, but it does so in a very interesting way. So let's say that this was a bacterium. Actually, no, I like the color pink, so let's use a color I don't like. So let's say that this was a bacterium. So the monocyte would defend us against this. It would attack this bacterium by engulfing itself around the bacterium. Okay, and when it does that, it kind of looks like it's eating the bacteria. It looks like it's eating the bacterium. And so that's a very interesting way of dealing with these invading organisms. So let's clear out that. So mono actually refers to the fact that this cell has a nucleus that's in one piece. And I guess a lot of these cells have nuclei that are in one piece. But it makes us wonder what types of cells have nuclei that are not in one piece. And that would bring us to a neutrophil. So this is a neutrophil. A neutrophil. And it has a nucleus, like I'm drawing in, that is broken up into several different pieces or segments. And the segments are still held together by little pieces of string. So this is called a multi-segmented nucleus. And even if you've never heard of a neutrophil before, I'm sure you've seen them before. And how do I know that? It's because neutrophils are actually the main component of pus. So if you, like anybody else, has ever popped a pimple, you've looked at a bunch of neutrophils. So what are the other types of myeloid cells? Well, we have this one cell that's called a basophil. Basophil. And it looks something like this. You might say, well, that looks an awful lot like a monocyte, and you'd be completely correct, except this cell has a very unique feature that the monocyte doesn't have, and that is that it has these bright blue granules in its cell's cytoplasm that make it stick out. And so the way I like to think of a basophil is like a blueberry muffin, and that reminds me that it has these bright blue granules in its cell cytoplasm. So the last type of myeloid cell we talk about, the last type of myeloid cell that we talk about is an eosinophil. It's an eosinophil, okay? And it has a nucleus that can sometimes be found in two pieces. So this is the first piece and this is the second piece, but that's not what makes it so unique. What it's really well known for is the fact that it has these bright, beautiful red granules in its cell cytoplasm. So those are all of the different blood cells, with all the lymphoid cells on this side and all of the myeloid cells on this side. So it turns out that all of these cells don't directly develop from a hematopoietic stem cell. Instead, they undergo multiple stages of development to mature into their adult form. But don't worry, guys, we're not going to hash out each of those different forms and their names and physical characteristics. Instead, we're going to make a very general statement. I guess we can put that up here. We're going to say that the immature forms of all of these cells are called blasts. And when the blasts mature, they are called cytes. Now, let me show you what I mean. So to spare you guys the agony of having to watch me draw out all of those different forms, I just pasted them in here. But we can see here that what we said about the immature forms being called blasts and the more mature forms being called cytes is true. So the T lymphocyte develops from a T lymphoblast, just like an erythrocyte develops from an erythroblast and a megakaryocyte develops from a megakaryoblast. So you guys get the pattern. The only wrench I'm going to throw into this pattern is with the neutrophil, basophil, and eosinophil, which all actually develop from the same cell, and that cell is called a myeloblast. So I think that that's a reasonable place to end our discussion on hematopoiesis.
Okay.
So what here is called T progenitor or B progenitor are the T blast.
Oh, I need again your sorry.
The micropoiesis as the name suggests, the natural refers to
One after the other.
blood and poiesis.
Okay.
Chiudo questo.
Avevamo quella. Okay, I think now is that. Okay, so as already mentioned in the movie, one population is made by cells called basophils, and the equivalent of these cells, which are in the tissue, are called mast cells. They are almost the same cell, but these are present in the blood and a different kind of morphology from the other one, but the same kind of function. So it's a cell which you can see in the blood with this kind of feature. It's almost impossible to see the nucleus as mentioned in the movie because it's covered by granules. Granules are vesicles containing very important molecules. So this is like a bomb, a living bomb, which can explode in any moment and create a very strong immediate reaction, an immediate inflammatory reaction, because the degranulation, the release outside of the contents of these many granules. This cell is about 10-15 micron of diameter and is very similar as the contents of granule to this one, the mast cell. This is a drawing of the ultrastructural feature of the cell, and this is what appears on when you see on the microscope. Also, this one are full of these granules, but are a little bit different in size, but they contain almost the same substances. So remember, basophil and mastocyte are characterized by this large amount of granules which are diffused all over the cell. And what they contain, these granules, contain three kinds of different molecules. One is called preformed mediators. The other one, mediators synthesized after degranulation. A mediator synthesized hour after activation. So one are the mediator preformed, presented already in the granules. And these are very important molecules. One of them, I'm sure you heard a lot of time, histamine. Histamine is a key molecule of inflammation. I'm sure you've taken or you see people taking a lot of antihistamine to block the reddish, the edema of the area, because histamine acts on the endothelial cell and make the endothelial cell to change, to dilatate, to become more, express more adhesion molecule, and to make the window from one to the other one. So histamine is a key factor of the contents of these granules, which are already preformed. So when you have activation of a basophil, of a mast cell, you have the release as a key mediator of histamine. But also you have heparin, and heparin is doing what? What is doing heparin? You never heard about?
No.
Heparin is anticoagulant activity, so inhibit the blood clotting. So it's very important. Then we have other substances which are very important with antibacterial activity. The mediator which are synthesized after degranulation, so takes a few hours to be released: thromboxane, prostaglandins, leukotrienes, platelet activating factor TAF, eosinophil chemotactic factor. So you can understand this molecule activated other cell of immunity or attract eosinophil chemotactic factor, since is the one who is attracting eosinophil in the area. But many hours later, you have the release of cytokines and chemokines. These are the powerful molecule released by basophil and mast cell. And we will see how the activity and the granulation of this cell in many cases is driven by antibody. And we will see later on the reaction with the called allergy, which in many cases is due to the hyper-release of this factor guided by a peculiar class of antibody called IgE. Okay, so here a mast cell. When you have an invasion of microbes in this area, the mast cell immediately degranulate, and you can imagine that this vessel, the blood vessel in the area, will completely change the structure. They become bigger, the area become red, mostly because of the mast cell release of histamine, and the small capillary become larger, and the area become full of liquid, embedded with liquid extravasating from the blood. The effect of mediator released by basophil and mast cell, activation of endothelial cell, which is a key factor, activation of endothelial cell. So the change, the capillary change, and the area became red and with edema, increase of vascular permeability, and anticoagulant activity. Anticoagulant activity because heparin, and the other two mostly because histamine. Attraction of neutrophil, eosinophil, and monocyte, and increase of bone marrow production of neutrophil, eosinophil, and monocyte. If we go back to the hematopoiesis, the hematopoiesis change your program of hematopoiesis following the factor released by mast cell and basophil. They release factor which increase the production of neutrophils. So if your patient, you see neutrophilia, too many neutrophils, means there is a reaction ongoing, probably driven by basophil and mast cell, which have perceived bacterial infection. So you change the normal composition or the normal production of granulocyte by the bone marrow. We have a smooth muscle contraction, and this is a dramatic factor of asthma. The smooth muscle of the bronchi, they contract, and the patient cannot give up the air, which remain blocked inside. Bronchoconstriction, increase of mucus secretion, toxic environment for microbes and parasites. So these are the effects due to the release of all these factors. Release immediately by degranulation or release a few hours later. So you can imagine if this cell degranulates, the area would be, vessel would be larger, the attraction, local attraction of neutrophil. If the reaction is very big, the signal arrives to the bone marrow, which change the program of normal production of the cell and will increase the production of neutrophil or neutrophil and eosinophil. You can put all the together, back together. Okay, this effect of mediator released by basophil. And this is very important because, as you imagine, this has an immediate medical effect. A doctor must know very well what is the role of basophil on the disease and defense. So the basophil, we saw very few. Very large population is due to neutrophil. Neutrophil has a larger population of cells present in your blood. As a majority of the cell, between 40 to 75, 80% is a regular range of neutrophils. So these cells are extremely important as a cell of immediate defense. If you have a child with a disease without the production, normal production of neutrophil, he will not survive because neutrophils are a line of defense which are of critical, immediate importance. This is a picture of the neutrophils, as already told you, as histology, regular histology. You see the nucleus, which is divided in lobi, can help the cell to become a very subtly pass through the small window between the cell. This is the appearance of ultrastructural appearance of the cell. So this is the nucleus. We have granules of different kind, which can be divided in granules, gelatinous granules, and secondary granules. We have a Golgi apparatus, we have a glycogen, we have primary azorophyll granules, we have a few lysosomes, mitochondria, and have four major activities. And I put some name as a very to help you to remember. First one, sentinel cell. We already saw they are distributed close to the mucosa. They can release a signal to activate inflammatory reaction. But also the cells, they can pose phagocytosis. You saw the movie, was that phagocytosis ability to ingest the foreign body, putting out pseudopods and engulfing the particle in endocytic vacuoles. But also what is very strange is called what we call Spider-Man effect. This cell release nets, and through this net of DNA, they attract microbes. And they have kamikaze effect. They kill themselves, destroying all what is surrounding. The contents of the granules of neutrophil are full of enzymes with very powerful lytic activities. They destroy everything, but destroy also the neutrophil himself. So the neutrophil, activated neutrophil, is a cell which is ready to die immediately in the reaction. You already saw that a little bit in the drawing I have prepared of the reaction. So these are the four major activity on neutrophils. This is due because of the contents of the granules. The azorophyll granules contain elastase, which is a very powerful enzyme to destroy protein. It contains bacterial peptide, which kills bacteria. The peptide, which are increasing the permeability of bacteria. They have powerful enzyme. And this against a list of different kind of contents, mainly enzyme and antibacterial substances contained in the other granules, and other contents of the third kind of granules. The main effect of the release of all these substances is rapid killing of invading microbes. Killing of the microbes because the granules are put outside of the cell. They kill the microbes, but also kill the neutrophil and also kill the normal tissue around. So you have a lot of dead cells, a lot of body cells dying, releasing the DNA, so you have the formation of pus. Establishment of an environment toxic for microbes, toxic for parasites, but also toxic for normal cell and neoplastic cell, a tumor cell. So the reaction of neutrophil is extremely powerful, but extremely dangerous. The contents of all these enzymes we saw, all these enzymes we saw here are terrible. They can destroy the majority of protein, of DNA, of structure. So they are very destructive protein, which can create an environment in which very few microbes can survive. But dying the microbes, but also dying the neutrophil, invading the area and releasing the granules. They can induce also the activation of the endothelial cell, increase expression of adhesion molecule by endothelial cells, and enhance the extravasation, the going out from the vessel of other cell from the blood, white blood cell, when can go out from the blood because the window between an endothelial cell to other one is larger, and also monocyte can go out at this moment. They can attract in the area where we have the release of granules other immune cells. So we have the establishment of a complex multicellular cell reaction, the inflammatory reaction, which is driven mostly by neutrophil. Neutrophil is a key player of this reaction. Enhancement of complement activation, and we will see later on, was the massive death of neutrophil, massive death of neutrophil, massive death of white blood cells arriving in the area, damage of host tissue, pus formation. Pus formation is a residual event. We have a lot of cells dying, and the residual of that is this strange substance, which is mostly done by the DNA released by the dying cell. So you understand what this inflammatory reaction is, which is mostly driven by neutrophil. Okay, neutrophil, first role, degranulation, release of the granules with all this effect of degranulation, okay? But also effect of phagocytosis. Phagocytosis, as mentioned in the movie, is the ability to engulf substances which are around, which are perceived by certain kind of receptor, which recognize some structure here and trigger the local movement of pseudopods, which form the pseudopod. They close and engulf in a endocytosis vacuoles in the foreign substance, which can be a bacterium, can be a dead cell, can be a parasite, can be a protozoa, can be many different kinds of cells. The pseudopods, which are produced, and is very important, we have the lysosome, and very soon, when the vacuole will form, the lysosome will fuse with that, forming the fusion of a phagosome, yeah, with a lysosome here, and form the phagolysosome, which start to digest. The lysosome is full of and the enzyme with elastase enzyme, we destroy protein, and we have normally the destruction of the microbe which are being invaded, and the residuals of the microbes are released outside after digestion. So we have the formation of the phagon lysosome, the activation of the enzyme of the lysosome, in which the enzymes are inactive, this digestion of the microbes, waste material are discarded by exocytosis. Okay? I think this is quite familiar to you. And these are the mechanisms by which they arrive. They are activated by platelet activating factor, by the chemokine which guide the arrival of the neutrophil. This you will see that later on, but also very important, they do release in a very fascinating way some net of DNA full of enzyme myeloperoxidase lactoferrin with antibacterial activity, and they trap the microbes around the neutrophil. So they release net of DNA around. They can also capture the microbes to different mechanisms. We'll see better later on. And we will see also that. Okay, we have two movies to see.
Sorry, which substances are involved in this Spartan extract? Or in this list? Not important or...
Well, lactoferrin mostly, but we will see. Let's
And the elastase and another one for the chemical and phagocytosis.
Yes, we will see.
This is really short. This is really short.
Yes,
Okay.
just to show you. Sorry. I wanted to see you the endothelial cell. They start to run on endothelial cell, which are a space adhesion molecule, and then is able to pass through this lesion which is formed through the cell and going out. And this is margination or exocytosis. We show you very clear the margination going outside of the cell. Okay? Don't check?
No, not at
Okay.
all.
Let's go to the last one. No, there's another one.
Another video.
Yes. Okay.
The neutrophil is a powerful and vigilant defender, constantly prowling the bloodstream in search of pathogenic invaders. When a target is encountered, it is swiftly engulfed and digested by the voracious scavenger. After a kill, the hunter does something unexpected. It casts a net to capture additional prey. Neutrophils are efficient assassins who expect to die, not reproduce. Their DNA is utilized as yet another weapon in their arsenal. When a pathogen is encountered, the neutrophil activates an enzyme, PAB4, to unpackage the tightly coiled chromosomal DNA into loose strands of sticky web-like material. The nuclear contents are ejected from the neutrophil, forming a deadly net composed of DNA strands interconnected by histones and impregnated with lethal antimicrobial agents, including myeloperoxidase, neutrophil elastase, and defensins. The newly formed net is set, capturing and killing any invading bacteria unlucky enough to swim into its embrace. Once its mission is complete, the toxic net must be deactivated and destroyed. Seronucleases chop the net DNA into smaller fragments that are easily ingested. Macrophages move into the area and dispose of the remaining net fragments, eliminating all traces of the pathogenic infection. Unfortunately, this defensive sword wields two edges. Failure to completely remove net fragments can result in the formation of autoantibodies directed against net components with DNA, histones, and PAD4. These autoantibodies can ultimately result in the development of autoimmune diseases, including systemic lupus erythematosus and rheumatoid arthritis.
Okay, did you heard? Okay, they do release this kind of net of DNA, which are very important to those enzymes which are linked to that to answer to your question. But if you have as everything, you have the good side and the bad side. The release of too many of this net or in certain persons, this can be the cause of induction of antibody against the DNA of the net, and can be the basis of a very dramatic human disease. It's called lupus erythematosus. So the formation of autoantibodies against DNA. Lupus erythematosus. Okay, let's go to another cell, which are eosinophils. Eosinophils change very much. Sometimes on 100 cells you can see any one, or you can see 7. You can see in me, I have normally 11, 12. It means I am allergic. And if someone is allergic, have an increase of eosinophil. And if the person who is allergic, let's say to a flower, and would go to the spring, the number of eosinophil will increase very much. This is just a very simple way to say with the blood count, the different regulation of the cell. So the reaction to certain kinds of substances due to eosinophil can induce very bad consequences. Eosinophil also has a key cell in fighting against worms. So if you have a patient with a large number of eosinophil and is not allergic, you may suspect immediately worms infection. They are very similar to neutrophil, but the contents of granules are different. So the staining with the color is different. The name eosinophils means they are like to be dyed by eosine, which is a staining normally used in the past for histological section. So neutrophils are stained by neutral stain. These are stained by acidic stain, eosinophil. And in histology, they have this feature with these granules, which are almost orange granules. And also they have primary and secondary granules. They have a special substance, which is called major basic proteins, which is substance which makes some crystal inside to the cell. So it's quite similar to neutrophil, but at the same time very different. What is very important to remember, the key point, one of the key points is a very short life of this cell. Neutrophil survive 5 days. So every day you produce a huge amount of neutrophils and you destroy your old neutrophil. Neutrophils are so important at defense cell, so you cannot afford to have old neutrophil. You need always to have new neutrophil, very effective, so they can survive only 5 days. There will be certainly a question in the test. What is the normal lifespan of a neutrophil? Day, month, year? And you have to remember, neutrophils survive only few days. Eosinophil can live even less, 6-12 hours, or can live a few days. So both cells are cells which are very continuously produced by your bone marrow. During this hour lesson, you have produced almost several million of neutrophil of eosinophil, new, and you have destroyed almost the same amount of cell because the balance remains the same. They have a similar activity, phagocytosis of microbes and small particles. This key factor, degranulation, so the release outside of the granules in a few minutes after activation, leading to the destruction of the invaders, and as well as the damage of the invaded tissue and the dying of the neutrophil and eosinophil. Before that, they can emit the net, this so-called Spider-Man effect, this very interesting net of DNA which are going around, which can trap the microbes and kill the microbe due to various enzymes linked to the net. They can also produce a secretion of cytokines, enzymes, and microbial protein and peptides. They can work as antigen presentation. Forget, we will discuss that in detail tomorrow. They have a very strong anti-helminthic activity, anti-worms, mostly eosinophil, and they might have anti-tumor activity. Okay. We pass a completely different cell. The last one, which is monocyte. Do you have some question about the granulocyte?
So the granulation is considered as a kind of exocytosis, or every time that a cell
Exocytosis.
and every time that a cell does the granulation die, or can continue?
Well, they die because the activity of what has been released outside. It's not they are dying because after the granulation they don't survive. They are alive, but then the effect of the contents of the granule, all the enzyme are not selective, and so kills the neutrophil as well as the microbes. Okay. Monocyte. Monocyte is very strange and different cell. We pass to this can be seen like a bomb, like a living bomb, neutrophil, eosinophil, ready, and also basophil. They release the contents of the granules, they die, they are very toxic. This, by contrast, monocyte are much more articulated cells. We have relatively few, between 4–9% of monocyte, except we have a chronic infection. In this case, we have monocytosis. We have a lot of monocyte in the blood. We produce more of this cell. The morphology is very different. The monocyte, I was told in the movie because they have a single, very big nucleus, bean-shaped nucleus, come un fagiolo. Bean-shaped nucleus, very few granules. They have some granules in the cytoplasm, but they are not granulocyte. They have some granules in the cytoplasm. You see at the electron microscopy was the nucleus, a lot of endoplasmic reticulum, so big synthesis of protein in this cell, a lot of mitochondria, and quite a significant Golgi apparatus, so means synthesis of protein. Is a large round cell, bigger than granulocyte, larger than granulocyte. But we have this cell change shapes, change name. For a long time was difficult to understand that one cell were really deriving from monocyte, because they are called monocyte when are in the blood, and are called with the general name of macrophages when are in the tissue. But also the old histologists were not able to understand that the Langerhans cell we saw already in the epithelial cells, the green cell in the first drawing I showed you of the skin, were macrophages which are a little bit differentiated. We're not able to understand the monocyte the alveolar and interstitial macrophages of the lung are nothing else than monocyte migrated in the lung. Are not able to understand that what has been called Kupfer cell in the liver are nothing else than differentiation of monocyte. Microglia cell, osteoclast, and even dendritic cells are late stage of differentiation of monocyte. So monocyte is a general cell which differentiated in various significantly different as morphology cell in the different tissue. And particularly, remember, osteoclast in the bone marrow is nothing else than a monocyte which have been, a macrophage which have been differentiated. What does it mean, macrophage? Macrophages mean two things. Is big, macro, is big. A phago is eating, the word, Greek word eating. So is a big cell specialized in phagocytosis, but also you can see the other way, is a cell able to phagocyte big stuff, big thing. So neutrophil and eosinophil are phagocytic cells, but they phagocyte small things, small debris, small bacteria. Here, macrophages can phagocyte very large substances. The morphology, as we saw already, the nucleus and the core. Lifespan, completely different. Your macrophages survive months. What survive neutrophil? Days. What survive eosinophil? Hour a day. So completely different situation. You produce every day during this lesson, you have produced probably 1,000 monocytes, but you have produced millions of neutrophils. Activity. Professional phagocytosis, a subsequent killing of microbes. So they are the phagocytic cell of your body. They are cleaning, they are destroying all the debris, all the dying cells are phagocyted by their very important scavenger function. Scavenger is the one who cleans the body. They are the cleaner cell of our body. Removal of old red blood cell, removal of cell debris, removal of dead cells and extraneous particles. almost any kind of particle. Normally, if you want to make a test of phagocytosis with macrophages, you give plastic bead, polystyrol beads stained with fluorescent body. So you can count the phagocytosis. So they eat everything. Any kind of foreign substance touching, interacting the pattern recognition receptor on our side can stimulate the emission of pseudopod and the phagocytosis. So they are professional phagocytic cells. They also secrete a lot of cytokine. They do not release granules with cytokine inside, like granulocyte. They do secrete of cytokine, enzyme, and protein. But also, besides phagocytosis, macrophages can be activated and have a killer activity, so can kill directly extracellular microbes and anomalous cells without phagocytosis. Can kill because it's able to phagocyte, but also is able to kill without phagocytosis because it secretes arachidonic acid, because it secretes reactive oxygen radicals, which alter the structure, the membrane of microbes, and can have a major role in antigen presentation. Okay, phagocytosis we already saw. We go again to see the microbes, emission of pseudopods, the microbe is engulfed. The lysosome perceive the presence of phagosome and fuse, forming autophagosome, and not phagosome, they destroy the microbes and eliminate the digested material. But also they can eat our cells and renew continuously the inside, since it survived for many months. So the protein or the monocyte can renew because it forms autophagosome, destroys the inside protein and form new protein and renew continuously. Have a lot of ergotoplasmic reticulum, and the plasmic reticulum seems it's say that this cell is producing a lot of new protein continuously. The endocytosis can be of different kinds. We can see this one is a typical phagocytosis, but can be panocytosis with liquid particles which are directly absorbed, can be endocytosis, which minor or micropanocytosis, different kind of endocytosis. Can also typical of macrophages, the emission of pseudopod, so long prolongation of the cytoplasm, very long, which have a receptor for certain structure present on certain microbes, and from that can attract the microbes and then invaginate them and form the vacuole of phagocytosis, which then fuse with lysosome and digest the microbes. So it can engulf the microbes which are adhering, but also can emit very long pseudopods and trapping and killing the microbes. So macrophages are killing the microbes because with the pseudopods, because of phagocytosis, but also because they release substances which are toxic for microbes outside of the cell. Sometimes the microbes have a complement structure on the membrane and we have a receptor, but we will see that in detail later on when we'll discuss of the complement. Okay, there are different kinds of receptor. We have lipidic receptor. We have mannose receptor to recognize a sugar. This is a pattern recognition receptor, which recognizes sugar, mannose, which is not present in our body. To recognize, where is this other one? Some lipids which are not present in our body. So a different pattern recognition receptor by which recognize different molecules which are foreign to our body. Okay. I begin to
In phagocytosis, phagocytes are attracted to the area of invasion by chemical products of the microorganism, phospholipid released by injured mammalian cells or by components of the complement system. The phagocyte moves into the area of invasion and then attaches to the microorganism. The attachment is mediated by a variety of surface receptors, including antibody, lipopolysaccharide, and complement receptors. For example, the C3b component of complement coats bacteria or other particles and then binds to C3b receptors on the phagocyte. This process of coating to enhance phagocytosis is called oxidization. The microorganism is then engulfed by the phagocyte into a vacuum known as a phagosome. Vesicles in the cytoplasm called lysosomes fuse with the phagosome, releasing digestive enzymes such as lysozyme and proteases into the phagosome. The structure resulting from this fusion is called a phagolysosome. Inside the phagolysosome, microorganisms are killed and digested. Finally, the digestive contents of the phagolysosome are eliminated from the phagocyte by exocytosis.
Neutrophils make up the vast majority of
okay, formation of phagolysosome. Okay. So, in different moments of this maturation, the influence of hormones, the different chemokines, contact locally, regulate the differentiation of the stem cell, hematopoietic stem cell in the different population. We saw here a critical point of division of monocyte, one side, and the other one become dendritic cell. Dendritic cell can be seen as a specialized kind of monocyte, which are very high plasticity and very strange. They are called dendritic cell because the cytoplasm have a lot of prolongation, like a tree, the branches of a tree, and a nucleus which is similar to the one of macrophages, but the cytoplasm is more active than the one of the macrophages. have a lot of mitochondria, so it means produce and need a lot of energy for their activity. Have a certain kind of cytoplasmic endoplasmic reticulum, so it means production of protein, and the size is similar to the one of macrophages. So we will see that later on. And derived from myeloid and lymphoid progenitor from monocyte, when monocytes are already in the critical point of maturation. And we have different kind of dendritic cell, what we call conventional, plasmacytoid, and other. We will deal with this course mainly with conventional dendritic cell. You must aware that exists also some kind of subpopulation of dendritic cells. These dendritic cells are probably the Langerhans cell, which can be both of macrophages or dendritic cell differentiation in the skin immature dendritic cell. When they mature, they change behavior. They have two stages of differentiation: immature dendritic cell, mature dendritic cell. Immature dendritic cell and Langerhans cell, they have a lot of phagocytosis and cytokine secretion. Mature dendritic cell, they are professional antigen-presenting cell. This makes no sense to you, but tomorrow or this afternoon, this will be much clearer to you, and we will go on in detail on this critical role of dendritic cell. Okay, we can see just the movie if you don't mind. You see all the prolongation of the cytoplasm, very, very massive prolongation of the cytoplasm of this cell. These are immature dendritic cells with very strong phagocytic activity. Okay, just come faccio a bloccare? Scusami. Here, at this point, we have a passage in maturation of B cell, T cell we will not discuss here, but we will discuss this strange kind of population called natural killer cell, which is the last cell population we will discuss in this presentation. Natural killer cell, normally called NK cells. A cell which is characterized to have just lytic granules containing two very important molecules you must be aware of, perforin and granzyme, are similar to a lymphocyte, but just have a little bit of this granule in the cytoplasm when seen histologically. Their activity is modulated by many different cytokines, which increase or decrease their activity. IL-4 decrease, but the majority of all the cytokines. But we will see that in the future. when we discuss better the role of this cytokine. And this cell, natural killer cells, are called natural killer because are cells always ready to kill. The first reaction of this cell is killing, except when the cell to be killed, the target cell, express something which inhibit the activity of the killing. So the logic of activity of NK cell is completely different from the one we saw so far, which is activation and reaction. NK cells in general are ready to kill, but then are inhibited. Yourself are not killed in this moment by natural killer cells because they do express certain molecules we will discuss later on, which inhibit the activity of the killer cell. So we have this molecule, which are the histocompatibility molecule, histocompatibility glycoproteins, and this normal interaction of the receptor of NK cell with our normal histocompatibility molecule deliver a signal which inhibit the activity of NK cell. So everything in the immune system, or almost most of the things in the immune system, are activated and they do react and kill. Here, they are ready to kill except when they are inhibited. So it's a reverse of the logic. And this is very important because if one of your cells have an alteration on histocompatibility antigen, or the histocompatibility antigen are missing, you don't have the histocompatibility antigen, the cell is immediately killed. We will see when we will discuss the histocompatibility molecule that these are different from you and you and you. So they give us, they provide our identification of ourselves outside. If the identification of ourselves is missing, what is called missing self, you cannot say you are you normally. So it means this cell has some anomaly because do not express the normal histocompatibility antigen on the membrane. The cell will be killed. It's an anomalous cell and will be killed. So the NK cells have a majority of inhibitory receptor on the membrane. And the dominant inhibition, the activity of this cell is normally inhibited. If these signals are missing, the cell can immediately kill the target, or can even be activated by other receptors and kill even better the target. This cell expresses irregular, anomalous histocompatibility molecule. The cell receptor, activating receptor designated in red, are activated, and they trigger the release of perforin and granzyme in the small area of contact between the two cells. NK cells establish adhesion interaction with many cells. The receptor interact like a synapses, a mobile synapses. The two cells are interacting one to the other one. They interact for a short period of time. This signal gives negative signal. The NK cell go and interact with another cell. Suppose this one which have altered histocompatibility antigen or missing histocompatibility antigen, non-negative signal, activating receptor can be activated and trigger the release of perforin and granzyme, which are out here, and digest the target cell. They induce nuclear fragmentation and chromatin condensation, and the cell will commit apoptosis or necrosis and will be destroyed by this enzyme, which destroyed inside the cell and first induce lesion on the membrane. They enter into the cytoplasm and digest the target cell. This is very quick event. It's called kiss of death, bacio della morte. So they interact for a very short period of time, no inhibition of the NK activity, the release of the contents of the granules, degranulization, microtubule organization in order to put the granule outside in the small area of contact of the target cell and NK cell. The release of the contents of the granules and destruction of the target cell. NK activity is triggered by activating receptor recognizing cell with a rarefaction or absence expression of histocompatibility class 1 glycoprotein, the histocompatibility antigens. They can kill anomalous stress cell, which express poor histocompatibility antigen, neoplastic cell, leukemic cell, which do not express histocompatibility molecule. Cell infected by herpes virus, by cytomegalovirus and other virus, which induce and block the expression of histocompatibility molecule. Or cell covered by antibodies with the called antibody-dependent cellular cytotoxicity, and we will discuss a lot about that in one lesson speaking about antibody. NK cells are also producers of a lot of cytokines and can modulate an inflammatory response, can regulate the adaptive response, influence hematopoiesis, induce maturation of dendritic cell, and can have a very important role in the fertilization, in the remodeling of decidual vessel in the placenta, and the induction of regulatory T cell. Most of this activity will make sense when we will go a little bit more in detail about the immune mechanism. So far, what you have to remember of natural killer cell is the ability to kill the cell which have no expression of histocompatibility antigen. And also they have this receptor for antibody which can guide their activity, but we will see that in detail later on. Okay, I'm sorry, if you don't mind. Is against the same? Is not against it. Può darsi che abbia fatto un errore.
No, stavo vedendo se non si è copiato.
Ah.
Every year, over 14 million people worldwide are newly diagnosed with cancer. That's why we created Cancer Breakthroughs 2020, a program with the ambitious goal of winning the war on cancer by the year 2020. To reach that goal, we're accelerating the development of combination immunotherapy as the next generation standard of care in cancer patients. We're also harnessing the full power of our body's own immune system by developing treatments which utilize natural killer cells, our body's first line of defense in the battle against cancer. Natural killer cells have the innate ability to rapidly seek out and destroy abnormal cells, such as cancer cells, by identifying markers of stress on the cancer cell and releasing toxic granules to destroy it. They're able to do this without prior exposure or activation by other parts of the immune system, which is why they're called natural killers. Natural killer cells are also able to bind to antibodies that have identified specific targets or antigens on a cancer cell and kill that cancer cell through a process called antibody-dependent cell-mediated cytotoxicity, or ADCC. The natural killer cell has two kinds of receptors: activating receptors, which put it to work, and inhibitory receptors, which are mainly used to prevent the natural killer cell from attacking healthy cells. But cancer is smart, and as it grows, it's able to outsmart our immune system by engaging killer cells, effectively putting them to sleep. Fortunately, we've discovered a unique variant of natural killer cells called NK92 that lacks inhibitory receptors, but has a broad array of activating receptors and can be deployed off the shelf. We call it an activated natural killer cell, or ANK. An ANK is always switched on and is able to rapidly target and kill cancer cells. To further improve the targeting and killing power of this activated natural killer cell, we've genetically engineered these ANK cells in several important ways. This unique platform is designed to offer multiple approaches to the targeted killing of cancer cells. First, we've created what we call high-affinity natural killer cells,
Okay,
or
sorry.
ANK, by genetically engineering a natural killer cell with a high-affinity CD16 receptor. The CD16 receptor allows natural killer cells to work with it.
It's very difficult to find a good presentation. Okay, last cell I wanted to discuss with you are endothelial cells. Endothelial cells are the key player of inflammation, as a cell which are established, they are forming the wall of capillary vessel and the small post-capillary veins. These are they form the tight junction, so they cannot pass through liquid. They are very permeable cell, but they completely change their behavior when they receive a signal by alarm signal by epithelial cell, we started to discuss this morning, as a cytokine, a factor released by the different sentinel cell, which act on this cell and change completely their structure. Inside, we have red blood cell here, or lymphocyte, passing very quickly through this small vessel. And you can see here a neutrophil, the extravasation or transendothelial migration, which is able, the cell, because it's been modified by the signal arriving from the periphery, form a lesion here and allow the passage of the cell and emargination. Or they establish initially some interaction because they become more adhesive. They express more adhesion molecule and establish first they are moving very fast in the capillary. Every time your heart bites. But here they establish some interaction because they become a reach of adhesion molecule, the first interaction, and then slowly by slowly they can pass through this small lesion. They can be established between one cell to the other one. And here it provides you a picture of this lymphocyte adhering to the surface of endothelial cells. These are red blood cells, and these are the adhesion molecule which can increase and establish the interaction with the lymphocyte. I think I've finished. Okay, so endothelial cells, they become more adhesive. The lymphocyte, the neutrophil, the macrophage establish lesions with that, and this allowed the final emargination, which is completely driven by the ability and the behavior of endothelial cells, which respond to the signal delivered by the periphery. So, endothelial cell enlargement increase. Capito ogni tanto?
Sì.
Too much. Okay. Enlargement increase adhesion molecule, mast cell and basophil degranulation, emission of nets, and neutrophil and eosinophil phagocytosis, killer activity, and this is professional emission of net degranulation. So this is a key factor. This is less important. Macrophages, Langerhans cell, dendritic cell phagocytosis, killer activity, secretion of cytokines, and release of reactive oxygen intermediate. Natural killer cell, killer activity, secretion of cytokine and chemokines, then lymphocyte, killer activity, secretion of cytokine and chemokine, innate lymphoid cell, secretion of very large variety of cytokines and chemokines, activation of mucosal reaction, and then we have also fibroblasts, which are localized on the barriers. We can release some kind of enzyme. Okay, these are the various molecules which are released by the different kind of cell. So we have peptide, protein, and cytokine. We have very big system of molecules. We will discuss for a very long time about this system of complement, which is produced by macrophages, by liver cell, and by lactoperoxidase thiocyanate H2O2 system, or the black coagulation, which have all antimicrobial activity, complement-dependent cytotoxicity, and alarm signal. Then this one we already saw the majority of this morning. And then we have a cytokine of interferon family, which can have antiviral activity and activation of the immune system. But all that will take different meaning in the future, I hope. Okay, this just to finish with all these cells are the key player of the inflammatory reaction, which is an exceedingly important defense mechanism. But I'll show by this time cover These are also the secret killer. The inflammatory reaction is very important, but is very dangerous. And chronic inflammation may be the engine that drive many of the most terrible illness of the middle and old age. And the aging of the person so much depends on how many of these inflammatory reactions have been taking place in this person. Because every time they provide a major stress of the body, major triggering of many activity of the body, which can be very dangerous. So what we try continuously is to inhibit, to block the inflammatory reaction. Too much of this inflammatory reaction. Just a little, not too much as normally our body is doing. This is a big mistake in the evolution due to the completely change of the lifespan of a person. The old age have no evolutionary meaning except in a very cultural society. So it was not important to have illness when you are old due to inflammation, because to be old have no evolutionary meaning. Once your reproductive period is finished, or not anymore at the top, when you are 20, 25, after that, your illness have no power on influencing the evolution. So we have this kind of problem with inflammatory reaction just because our life completely changes the society. And when the humans start to live for a longer period of time, say 20, 25 years, which is a natural lifespan, not technological, before inventing dressing and other kind of things of this kind, the inflammatory reaction become a fearful kind of problem. And this also, you will have probably be involved as a doctor many times with the problem of vaccination. As you know, now is very controversial area, because they say, what about have infectious disease when you're a child, like a morbillo, this kind of disease, smallpox, chickenpox? They are really, everybody done. Yes, with a lot of inflammation. Vaccination can provide you not to have this inflammatory reaction. When you have this kind of disease, you take aspirin, you take a lot of tacopyrine and so on, a lot of paracetamol, a lot of drugs to dampen inflammation. But in any case, your body is exposed to a major stress. So we try to avoid, as a doctor, the maximum of inflammation. Take the inflammatory reaction which is important, which is essential for the induction of immune reactivity, to very low level. Because every time we have a systemic inflammatory reaction, as the one we use to control a viral disease, we have a problem in our body. We have a major stress of our body, which can have fearful consequences within the middle age. So heart attack, cancer, Alzheimer, and many other diseases, particularly autoimmune disease, can be due to repeated inflammatory reaction. Okay? So what time is it now? We have half an hour. What? Okay, we can just start to try to introduce this concept. Many cells. We saw already epithelial cell, macrophages, neutrophil, eosinophil, endothelial cell, basophil, mastocyte. This cell should interact with the immune system, should interact. You have a communication. And we have major communication code of the immune system. Molecule communication which can tell from one cell to the other one what is going on, what one cell has perceived, and transform a signal received from the receptor in a signal which diffuse in the immune system. So to talk, the communication within the immune system. And we have different kind of communication system. We just saw this morning a little bit of alarm signal, which are delivered by epithelial cell and sentinel cell, which are perceived by the pattern recognition receptor, which are expressed by the cell of innate immunity. This cell perceives the presence of invasion, of anomaly, of a barrier which has been broken, and deliver this kind of signal which put in alarm many cells of the immune system. Then we have another system which is more general, and you already saw, you will see in other courses, which are hormones. So molecules which diffuse all over the body in different periods of the life, and they act on endocrine, expressed and produced by endocrine cell, their specific receptor, and can also be expressed by immune cell. So hormones can also influence the immune reactivity in a very general way. But then we have a communication code which is very typical of the immune system, which is due to this molecule called cytokines, which are expressed and produced by the immune cell, which interact this molecule with very specific receptor. Each cytokine has a specific receptor, and the receptor can be expressed or not expressed in different stages of the survival of the cell, and is expressed by the cell of the immune system only. So this is a typical code of communication of the immune system. And then we have, and we'll discuss, I don't know if this afternoon probably, this histocompatibility molecule, which are expressed by all the body cells, and which is very important code for activation of T lymphocyte, which are the cells which follow the code provided by histocompatibility molecule. And then we have a different kind of membrane ligand, some molecule expressed by the immune cell, which interact one cell with the other one and are expressed in general through the lymphocyte. So what we want to just introduce now initially, and then we will see early this afternoon, is the cytokines. This communication code, which is named in general the name of cytokines. Cytokines are molecules which are released by the cell of the immune system as a message, which is secretion of molecules collectively called cytokines. The cytokine message is received only by the cell expressing a specific membrane receptor. So it's a play between the message and the receptor. And this cytokine in blue is acting only on the cell B and not on the cell C, because this one is expressing the receptor. And these are probably two lymphocytes, to the same kind of cell of the same population, but one has been activated in a way to express a receptor, and the one does not express a receptor. So the receptor is not always expressed. The receptor is expressed in certain stage of maturation of the cell, or in certain stage of activation. So the cytokine, this message is perceived specifically only by the cell, which in this stage, peculiar stage of activation, or peculiar stage of differentiation, express the receptor. The expression of a receptor for a cytokine changes continuously during the life of a cell. The cytokines are main family of cytokines. And these are dealing with a major problem of the immune system. Too many names. Too many names. Troppi nomi. We have many names to say something similar. The cytokines is a general name for this molecule. But initially, this molecule, or at least a few of this molecule, have been discovered about 40 years ago, 50 years ago, during a meeting that had been taking place in a town called Interlagos. And everybody, the scientists gathered there to define these new molecules released by the cell. And this was Interlagos, and people were also a little bit drunk after a big banquet. It was an evening session. We decided what name to give to this molecule. And the name was decided to be this one, interleukins, because Interlagos, interleukins. But at the same time, because leukocyte, interaction, and kines, kineo, put in movement. So in this meeting, I was part of this meeting a long time ago, people decided to call this molecule interleukin, at least some of this molecule. And to put the name of the letter IL, and dash 1, 2, 3, 5, 22, 23, we saw many as progressively they are identified and take a new number. So many cytokines are called interleukin. And interleukin and cytokine are exactly the same. But progressive cytokine is a general name, and this is a name of a large group, a large family of cytokines. Okay? So many times we will see interleukin 1, we will see interleukin 2, interleukin 4, and so on, are some cytokines. Other people doing completely different job. We are speaking about something which was being discovered, so we're not knowing what was something appearing in the fluid of tissue culture, so difficult to identify. Other people, mostly microbiologists, working with viral infection, studying as the virus infects the cell. So sometimes the cell releases something which interfere with the viral infection, impede viral infection, and call this molecule, which is impeding viral infection, called interferons. In Italiano, interferoni, interferons. And this molecule, interferons, have been studied by microbiologists. And have been called interferon alpha, interferon beta, interferon gamma. These are nothing else than cytokines, which are sometimes very similar to interleukin, just have a completely different name because of historical reason. These have been discovered initially by microbiologists in function of the ability to interfere with viral infection. Okay? Then other group of people was very impressed by certain cytokines, which in a certain experimental system, very peculiar, this cytokine induce the killing, the dying of the tumor cell, and called this molecule tumor necrosis factor, alpha, beta, gamma, and so on. These are nothing else than other interleukins, which unfortunately have been initially get this name, which is very impressive, tumor necrosis factor, or is better known as TNF, and so was difficult to change this name since it was already so diffuse in the imagination of the immunologist. So instead to become interleukin 43, they remain TNF alpha, TNF beta, just because historical reason, and also because it's much easier to remember what is TNF is doing, while it's difficult to remember what interleukin 23, 24, 25 is doing. This is less emotional. This is very emotional name. So the name is remaining, but it's just making confusion. It's not logical. Then completely different people working on hematology and studying the maturation of stem cell in the bone marrow discovered there were factors which very, very important to influence the maturation.
Just press OK on the remote for the television.
No, it's okay. Oh, excuse me. Other people, completely different hematologists, working on the maturation of stem cell from the bone marrow. So the maturation of stem cell is influenced by the secretion of some factors, which are nothing else than cytokines, which are very similar to some of these cytokines with a number, and they call colony stimulating factors. What they were doing, they were culturing bone marrow cell in the petri dishes and adding this factor and showing that stem cell from the bone marrow, we saw this morning in the movie about the maturation of stem cell, in the presence of these cytokines, produce granulocyte. So the colony differentiation, do you remember the differentiation of the different maturation? So the stem cell, in the presence of this factor, produce only granulocyte, activated this differentiation program we discussed this morning. So they call this molecule GCSF, G colony stimulating factor which increase the differentiation of bone marrow stem cell toward granulocyte, toward neutrophil, eosinophil, and basophil. Then they discover another one, which is called GM-CSF, a factor which is nothing else than the cytointerleukin, which is nothing else than the cytokine, which is inducing the maturation of the stem cell toward macrophages and granulocyte. And so they call GM-CSF, granulocyte macrophages colony stimulating factor. They discover another one, you can imagine, MCSF, macrophages colony stimulating factor. So they call these cytokines, which influence the hematopoiesis, like colony stimulating factor, because have been discovered culturing colony of stem cell, adding this factor, and seeing they transform in granulocyte, in mixed culture of macrophages and granulocyte, or only macrophages. Okay? And another group of people working on another molecule identify other two cytokines, which are instead having the name, maintain the old name, which transforming growth factor alpha and transforming growth factor beta. But all that are exactly similar molecule called cytokine, and they share the majority of typical feature of this molecule. Okay, I think we can stop here the introduction, and we will go on this after that. Okay?
I can start the series.
Ragazzi, va bene come faccio lezione? Troppo veloce, troppo piano? Riuscite a capire come devo cambiare? Titolo poi.